Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R software. So you can recall that in the last lecture we started a discussion on the preparation of data, in the sense that data is given to us for data analysis in different formats and we want to bring them inside the R software. So in this context we have discussed about CSV file and TXT file, and we discussed some basic operation about them. So we will continue on the same discussion, and in this lecture we are going to talk about two types of data files. One which are created in a spreadsheet format, like as the files which are created in the Microsoft Excel, which is a very popular format for storing the data. And next is data frame. That's a special format which is available in the R software, and it is very useful when we will try to learn different types of statistical techniques. So let us begin this lecture and we try to understand that how are we going to import the data in the MS Excel format, and then how to do the operations in MS Excel format file and the data frame file. But before that, I can tell you that in order to read the file from this MS Excel format, you need a package read Excel. So that you need to first install, and then you can do the operation. So let us begin our lecture. When we want to import the data file which are in the format of a spreadsheet, for example, this is one of them is popular is Excel file, which is created in the Microsoft Excel package. So in order to import such data file, we need a special package which is read Excel, READ Excel. And this package has a function read_Excel for reading the Excel files, right? And when you try to understand the spreadsheets, then the spreadsheet may have more than one actually sheets, and those sheets are given a number or a name, right? So we will try to discuss here how we are going to read the file, and when we use this command read_Excel, then usually it is reading only the first sheet of the Excel spreadsheet file, right? So first you need to install the package using the command install.packages, and the name of the package is read Excel, READ Excel, all in lowercase alphabets, and then you have to upload it by the command library, LIBRARY, right? So that you try to do. In the meantime, I will try to explain you what are the different commands. So we know that this Excel file have two types of extension. One is .xlsx and earlier is one is .xls. Right, earlier the file name used to be only .xls. Later on with the newer version, the file extension was made .xlsx. Right. So if you want to read a file, then the command is read_Excel, and within the parentheses, within the double quotes, you have to give the file name. And then in case if you want to read a particular sheet of the Excel file, then you need to specify either the sheet number by the command sheet_number, or by the sheet name sheet_name within the double quotes. So the command will become read_Excel within double quotes the name of the file, and then after that either sheet number or sheet name. Remember, sheet name has to be given within the double quotes. So in order to explain you this concept and this functioning, I have created a very small data file, and which I would like to show you here. This is the same file which I have created in the earlier lecture also as CSV and TXT file. So I have created this type of file. You can see here the columns are name, city, age, salary, etc. And then I have taken a very simple data set: AA, BB, CC, DD, EE. The cities are Kanpur, Delhi, Mumbai, Chennai, Kolkata. Ages are 20, 25, 30, 35, 40 at an interval of 5 years. And the salary is in thousands, like 50, 60, 70, 80, 90 at an interval of 10 years. So if you try to read the sheet number 1, then you can see here I am adding the command here SHEET is equal to 1. And then the command I am using here is read_Excel, and within double quotes I am giving the name of the file, and this data is stored here as data XLS. Right, and if you try to do it on the R software, it will come out to be like this. that you can see. Right, so this is the name, city, etc. And here you can see that these names are just stored within the quotes. So there is nothing like a dot or double dot which happen in the case of CSV and TXT files. Right, and this is the data which you have obtained. Okay. So now the same thing, if you want to extract the information or data on a particular variable, then you have to just follow the same instruction, that you have to write down the object name, dollar, and then the name of the variable. For example, here if you want to extract the data on the variable city, then you have to write down here data XLS $city, and you will get here this data. Then similarly, if you want to get the data on the age, then once again I would say you please try to copy the entire name, right? So and then you will get here this data. And similarly the data, and if you want to operate, for example, as I told you earlier, some statistical function over this data, then the advantage is that if I use here only a mean of data XLS dollar of age, then it will come out to be here 30. Right, so that is the advantage of using this thing, and you can see here, this is here the screenshot of the same operation. Right, and similarly, if you want to limit the number of data rows to be read, then you can additionally use the command n_max is equal to 3. So it will read only 3 lines and of the data set, and the command will remain the same, read_excel and whatsoever be the name of the data set. And if you want to read say any particular range of this data, then you can use the concept of A1 or R1 C1 notation. For example, if I want to read the data from a data set from the range from C1 to E7, or say R1 C2 to R2 C5, then I can give the command like this. You see R1 C1 and R2 C3 etc. They are the row column notations to indicate a particular address. For example, R1 C1 means the row column, I mean R means row, C means column, and 1 means first. And R2 C3 means the whatsoever be the cell in the R2, that is the second row, and C3 which is the third column. So this is how you can do it here without any problem. So for example, here if you try to see, if I use the command here, this n_max3, then you can see here in the same command, read_excel example3 excel.xlss, I am using here the command n_max is equal to 3. So you can see here only the first 3 rows are indicated, right? And this is here the screenshot. You can see here there are 5 rows, but only 3 rows are being here used actually. So let me try to show you these say examples on the R console before we move forward. So let me try to, I already have installed this package, and now I have to simply load the library read Excel that I already have done. So now if you try to see, I have created this data XLS. So it is here like this. And in this data XLS, if you want to know about the information on the salary, then you have to use data XLS, and then here the name of the variable. I have simply copied and pasted, including the quotes actually, right? So this is how you can do it. And suppose if you want to find out the mean of these salary values, then you see it is very easy to use the function here mean on these values. So you see the advantage here is that you are not going to disturb the entire data structure, but you are simply trying to read it only from the one thing. Means from the same data structure you can extract the variable, and then you can conduct your statistical analysis by implementing different functions. Now simply if you want to write down see here n max is equal to 3, that means you want to read at most 3 values here, then you can see here this is here like this. Then it has only here 3 values, whereas in the original data set there are 5 values. Right, so you can see here that was pretty straightforward, pretty simple. It's not a difficult thing at all. And after that, I want to give you some idea about data frames. Right, data frames are also similar to the spreadsheet. And data frame has an advantage that it can combine the data on, say, categorical, that is character or factors variable, as well as the numeric variables, which are of equal length, and each row in the data frame contains observation on the same unit. Just like as an Excel file, you can see here that in the Excel file also, what are you doing? This is the name AA, its city is Kanpur, age is 20 years, and then the salary is 50,000. So every row is containing the information on the same unit. So the advantage is that one can make changes to the data without affecting the original data, like others, and can combine numerical variable, character string, and factors. So different types of variables also can be combined here. And data frame, if you try to understand, is similar to the spreadsheet, where the columns contain variables and observations are contained in rows. That you have seen actually, because in the spreadsheet also you see these columns are here like this, and the rows are containing the numerical values. So now, in order to give you different examples here, I am going to use here a built-in package MAS, MASS, all in uppercase alphabets. Actually, this MAS package is associated with the book Modern Applied Statistics AS+, which was written by Venables and Ripley. So this MAS is the short form coming from, M is coming from modern, A is coming from applied, S is coming from statistics, and second S is coming from S+. So S+ was a software which was very similar to actually R. Actually S+ was developed earlier, and based on that R was developed as a open source software. So that is why this package was imported, so that people are comfortable in using the same commands and same example in the R also. Right. So, and in this package there is a data set which is in the format of actually data frame, and its name is Painters, Painters. So, and actually this Painters is trying to give the information of different painters, their name, their composition, drawing, color, expression, school, etc. So if you try to look on the R software, first you have to use the command library to upload the package MAS. So I will use library MAS, and then I will try to show you the data set Painters. So it will actually look like this. These are the name of the painter, Daudin, Da Vinci, Del Piombo, etc. And the details of their painting, like as the composition, drawing, color, expression, school. For example, Daudin composition is value is 10, drawing is value is 8, color is 16, expression is 3, and the school is A. Right. So you can see here that every name of the painter is serving as a row identification. Right. So if you try to take the first row, then first row is giving the information only on the painter Daudin. Right. And if you try to see on the R software, it will look like actually this. I will show you. And now the thing is this, you can see here, this is a big data set, and whenever the data set comes to us, we want to have the basic information. For example, what are the row names, what are the column names, etc., etc. So I'm just trying to give you some basic operation about this data frame. So if you want to know the names of the rows, then I have to use the command here, row names, ROWNAMES, and inside the parenthesis, the name of the data frame. Right. And similarly, you can see this is the screenshot of the same painter data set. And similarly, if I want to know the names of the columns of the data frame, then it is call names, and within the parenthesis the name of the data set, where that is painter. So you can see here, which is composition, drawing, color, expression, school, etc. Right. And now if you try to see in this data set, it has 4 numerical variables like as composition, drawing, color, and expression, and one variable is a factor variable like as a school. You can see here in this like as composition, this is numerical, drawing is numerical, color is numerical, expression is some number, school is something like ABCD. Right. So now whenever you get a new data set, there will be different types of variables, and you would like to know what are the nature of those variables. So in order to do this thing, I can use here different types of command. For example, I want to know whether the variable school is a numeric variable or not. So I can use here a command is dot numeric, and inside the parenthesis I will give the name of the variable, which can be extracted by painters dollar school. It is coming out over here false, right? So because school is something like ABCD, so that is why it is telling you it is not a numeric variable, because it's a character, right? And similarly, if you try to see the drawing was given by some number. So if I use the command here is dot numeric and painters dollar drawing, then it is coming out to be true. That means the variable drawing is a numeric variable. And similar, if you try to see here, now if I say is factor painters dollar school, that means the variable school, is it a factor? The answer is coming out to be true. So you can see here the same thing when you carried with the command is dot numeric, it was coming out to be false, but now if you are using is dot factor, it is coming out to be true. That means the variable school is a factor. And similarly, you have seen that drawing is a numeric, but if you try to use here the command is dot factor for the drawing variable, it is coming out to be false. So this is how we start playing with the data. As I told you, the objective of this course is to make you familiar that how are you going to use the first hand tools in the data set for the data analysis. So these are some of the steps what we try to do in the beginning, right? So as I told you, if you want to extract the information on any particular variable, then you simply have to use the name of the data set and then the dollar operator and then the name of the variable, right? So similarly, for example, in this painters, if you want to extract the information on the school, then you have to write painters dollar school and you will get here this data. So you can see here, this is the same type of command what you have used in the CSV, TXT and as well as XLS files also. But now you will see here, these are the values and it is giving you here the labels. Labels mean they are A, B, C, D, E, F, G, H. These are the labels by which the data has been given, right? Now if you want to extract the information for a particular cell, actually that can be obtained by something like as we did in the case of matrix by using the row column address. So for example, if you want to know that for the painter Dow Odine, what is the value of composition variable? So I can use here the command like as name of the data, which is painters. Then within the square brackets, I can write down within double quotes the name of the painter and the name of the variable, and it will come out to be here something like here 10, right? This you can actually see. And so I think before we go into more detail, let me try to show you these things on the R package also, so that you can feel confident about it. So first I will try to use here the command here library mass, so that I can upload it, right? So you can see here the painters data is here like this, right? You can see here this is the data, composition, drawing, color, expression, school, right? And similarly, if you want to extract here the information on say this here expression, so I can use here painters dollar expression. It is here coming out to be here like this. And if you want to extract the information on the say school, then painters dollar school. So you can, yeah, I made a typing mistake. Yeah, it's a painter dollar school here is like this. And you can see here that's pretty interesting. As I told you in the earlier lecture about the use of here actually null. So you can see here I made a variable name SCHOLL. That was a spelling mistake, but it said no, there does not exist any variable like SCHOLL. So that's a good example to explain you how NA and null actually differ. Right. So if you try to see and then if you want to know here the row names and column names, like here what I shown you, you can see here, right, something like here row names. So I can just use here row names, and similarly I can say here call names, right? So these are the names of the columns, right? So this is how you can do it. And if you want to see here is not a numeric, whether this school is a numeric variable or not, so you can see here it is coming out to be false. And if you want to use here is dot factor, yes, it is true. So similarly, you can go for other operations also without any problem. And yeah. Now after this, I want to show you a couple of more operations which are very simple but useful for us. Sometimes from a bigger data set, we want to extract a subset of the data. For example, from the painters data, suppose we want to know that what is the data set corresponding to school equal to F. So this can be done by using the command subset, subset. So for example, if I want to know that in the data set painters, what is the data set corresponding where school is equal to F. So here I am using two equality sign because that's a logical operator. And I use here the command subset. So you can see here that school is coming out to be here F, and all this data set which is corresponding to school equal to F is coming here, right? So similarly, if you want to find out the subset from this painter data set, that what is the set of data where the composition is less than equal to 6, right? So you can see here that I am using here the command subset, then painters, composition is less than equal to 6, and you can see here all the values here of composition are less than equal to 6, and this is the required data set. So that you can see that without affecting or disturbing the original data set, you can find out the subset of the data set. And similarly, if you want to make more these operations, for example, if you want to ignore some of the columns, then it is also possible. So I will use here the command here subset because we want to get a subset of the data from the data set painters. So my objective is that I want to remove the column numbers 3 and 5, right? What are those column numbers 3 and 5? You can see here, these are here colors and here is school. So I want to remove this school and colors, and I want to have a data set where school is equal to F. So I will write down here school is a double equality sign, which is a logical operator, equal to F, and in order to eliminate the columns, I have to use the command here select select with C and within the parenthesis -3 -5. So as soon as you say -3 -5, the R will understand that the third and fifth column have to be eliminated. So now you can see here this will be your here data set, and this is here the screenshot. The two columns have been eliminated and all those places where school is equal to F is given here. Right. So you can see here this type of operation can be done, and similarly, if you want to split the data set at some particular categories, then this can also be done. For example, you can see here the school here is a categorical variable which is taking the values A, B, C, D, E, F, G, H. Suppose I want to split the entire data set according to the say school variable. So I will use the command here split the data set painters, and now the variable name by which I want to split. So painters dollar say school, and whatever is the data set I am trying to store it in the split it variable. So you can see here this is how it will actually come. This first data set is corresponding only to here school A. You can see here. The second data set is about B. Third data set is about C. Fourth data set is about D, and then next data is about E, then F, and then after that G, and here H. And all these things you can see in this say screenshot A, B, C, D, E, F, G, H. Right. So now you can see here, now I would try to show you these operations on the R console also, so that you become more confident about it. So first let me try to show you how you can extract the data on the Udine with composition variable. So you can see here, this is here like this 10, right? And after that, suppose if you want to have a subset of the data where the school is equal to here F, so you can see here, this is the data set. Similarly, if you want to have the data set where you want to have this subset is equal to painters, So you can see here, this is here coming out to be like this here painters. And similarly, if you want to remove the third and fifth column here, then you can see here in the same data set you are trying to give, it will be easy for you to compare here. Here you have the data set where school is equal to F with all the variables. Now you are removing the third, which is color, and school variables, and this is the required data set what you have obtained. Right. And then after that, if you want to split it, it will be a long window, but still I can show you here. So you can see here. So as soon as you use here the command split, and the split has to be done with respect to dollar. So you can see here this is for A, this is for B, and others groups have been created. Right. So now you can see here that doing the operations in data frame is not actually difficult, including in Excel file also. Well, my objective was that I wanted to introduce you with the concept of data preparation. Because whenever the data comes to us, the first job what we have to do, we have to prepare the data according to the need and requirement of the statistical tool. And sometimes we have to extract the data. So I wanted to show you that with these operations, you are not really going to modify or alter the original data set. But from the same data set, you can make different type of operation, and without looking at the data set, you can extract the relevant data set and conduct your statistical analysis. Data frame and is also a very important aspect where there are many more operations are possible, but I have taken only some limited operation which are going to be useful for us in the forthcoming lecture. So now I would like to end here this lecture, but your job starts here now. Please try to create some data frame yourself, which is very easy just by using the command data.frame, and within the parentheses you can give the variables. Those things you have to do it yourself. Try to take some Excel file and try to extract the data, try to manipulate the data, try to create different types of subsets of the data according to your need, and try to get conversant with these operations, because they will be the something like the beginning operations which you will try to do as the first hand operation when the data comes to you. And after that, the statistical aspect will come into picture. So now I will finish with the data preparation also, although there are many more options, but I will leave it up to you that you please try to see into different types of files which can be which can be imported to the R software, but it all depends on your requirements and need. So you try to look at it, and I will see you in the next lecture. Till then, goodbye.